should use, so I decided to use all the machines and computers in the theatre, including Martin Mac ultralights, which are moving lights, light-emitting diodes, Maya UPA 1P speakers, a DPA boom mic, Shaw ADX1M radio transmitter, and 8 PTDS propane projectors. I had 2 hours to answer the 19 questions, but I spent 38 minutes doing moaning and groaning, which meant I only have 4 minutes to answer this question. Show that a triangle with sides that can be written in the form n squared plus 1, n squared minus 1, and 2n, where n is greater than 1, is right-angled. And this is what I wrote. Start the clock. If a triangle is right-angled, one of its angles will be 90 degrees and will therefore follow Pythagoras' theorem. Pythagoras said that a squared plus b squared equals c squared. To put it simple, if you draw squares on the outside of the 3 sides of a right-angled triangle, then add together the area of the 2 smaller squares, this will be equal to the area of the larger square. And this is only true if the triangle is right-angled. Come on, Bluey. Yes! The A-level question is the algebraic formula for making right-angled triangles. N squared plus 1 is the largest number in the equation, which makes it the hypotenuse, which is the longest side of a triangle. Now, to find the area of a square, we must multiply the length by the width. So, the area of this square is 2n times 2n, which equals 4n squared. The area of this square is n squared minus 1 times n squared minus 1, which equals n to the power of 4 minus 2n squared plus 1. Now, if we add these 2 squares together, this equals n to the power of 4 plus 2n squared plus 1. Now, we need to find the area of the square and the hypotenuse, which is n squared plus 1 times n squared plus 1, which equals n to the power of 4 plus 2n squared plus 1, which is the same term. So the area of the 2 smaller squares is equal to the area of the larger square. So all my squares fit together to satisfy Pythagoras' theorem. So the triangle is right-angled.